All right, welcome everyone to this week's Xojo webinar. This week's topic is gaming, and I think this will be a pretty fun one, especially for me because most of the time you're just going to see me playing games probably, which is fun for me, again. I want to remind everyone that Xojo 2014 Release 2 came out earlier this month, so if you don't already have that, feel free to head on over to our website and download it. And I want to also remind everyone to feel free and ask questions as I'm talking. They show up on my question window on the other screen, and I will get to them at appropriate points throughout the webinar. So let's jump right in. See if this works here. All right, so we're going to talk a little bit about making games with Xojo. Everybody likes games. So the main things that you need to focus on when you're creating games at Xojo are how you're going to handle your drawing, and you're pretty much going to use a canvas. So pretty much if you're making a game, you're probably going to end up with just a canvas on a window, and you're just going to work with the canvas. You're not likely to be using many or even any of the Xojo built-in controls, and that's kind of just the way gaming is. It all tends to be custom layouts and look and feel and whatnot. Games often have animation, and to deal with that, you're going to be working with timers. And those are pretty much the two main ingredients for creating games with Xojo. Everything else you'll have to work with by writing some code. Now, Xojo does itself come with some example games. There's some pictures of a few of them. First one is Sliders, which doesn't really use any specific graphics, although this stuff is, the tiles are drawn using a canvas. There's the Jewel game that is kind of like Bejeweled, if you've ever heard of that, where you got to match the three different, you got to match three or more of the different colored jewels or gems that appear on the screen, and then they disappear and new ones appear, and you get points for that sort of thing. And then, of course, there's a classic Falling Blocks demo that is obviously some sort of Tetris lookalike. So let's just jump out here and take a look at each of these three games. So let's first open up the Falling Blocks project. So you can see here the main window. I mean, it does have a few Xojo controls, labels primarily here to show information, and then there's a button to start or stop the game. But the main area is just a canvas subclass in this particular case, and that's where all the drawing happens. So if I run this here, we can start the game, and I can use the arrow keys to play a fun game of Tetris. And here's where you get to see how bad I am at playing games in general, although Tetris is always one that is fun to play. See, I'm already stuck. I got a hole. Anyway, I don't want to get too hooked and keep playing games all day. But you can see how that works. Graphics are drawn. They're moving down. Pretty straightforward. So, as you might imagine, most of the game is completely done using this canvas control. So you can see right here that it's selected, and if I expand it on here, you can see there's a few pieces of code that are processing when the end of game has been reached, which keys have been pressed, if an entire row has been filled up, and calculating the score. And there is a timer on here that is responsible for essentially updating the graphics. And then the rest of the code is on the Falling Blocks canvas subclass. which has a variety of support methods to the paint event handler, which is very simple, and it just calls the support draw game method. And as you can see, looking through all this various code, things are just drawn. And that's often how games are done. You just have to draw things over and over, and you have to track the position of things, what's happening with your game, what you want to happen if certain pieces reach certain areas, that sort of thing. But you can see that on a very high level, it is simply just a paint event that is drawing things onto itself. So this falling blocks example is included in your examples with Xojo, so you can always grab that one and play around with it. Let's take a look at the next one here. This is the Jewel game. And you can see the first thing that shows up selected here is a picture. And this is just a graphic that has the different jewels that are used kind of in one picture, and then they're kind of cut out as needed by the game. And that can often be faster than having individual pictures. I suppose it depends, again, how you've designed your game, but you do see this particular technique a lot where all the graphics are kind of combined into a single graphic file and then chopped up as needed. And again, looking at this, you see a window with a big jewel box on it, which is a canvas subclass. A label, and again, a button to start the game. So let's run this one. And this particular one, you click on 2 pieces, and when you get 3 or more of them in a row, they disappear and new ones drop down. You can see this one doesn't actually have any animations. The pieces are just immediately replaced. And then as you replace them, then they're removed. Points are calculated based on whatever formula a particular game needs to calculate these sort of things. And again, you'll see the 2 main components here, a canvas and a timer. The timer essentially is calling a playing method and doing a little more checking to see if it should show a hint if it looks like the person is stuck. And the canvas, again, has some code in various event handlers that are defined by the main canvas subclass, which is outside here. And you can see this, again, has a paint event that is simply calling a method that is responsible for doing all the drawing of the tiles. And then there's also other events that are handling where things were clicked, determining where stuff was clicked so it knows which tiles you were selected, if a second tile was selected to swap them, and then call methods that will check if there is a match so that all of them can be removed and then continue down its merry way. And as you can see, quite a bit of methods are needed to do just that fairly simple process that I just described. But the overall technique is the same again, canvas and a timer. All right, the next one we want to look at here is the sliders game. And this is just the simple puzzle where you have numbers and you have to slide the tiles around to get them in numerical order. So as you click on a piece that's next to an empty slot, it will slide into the empty slot. And the goal is to get all of these in order. Sometimes I'm good at this, sometimes I am not. Obviously, it's a lot easier when you just have 3x3 grid, and this particular one lets you go up to larger grid sizes. So looking at this particular one, again, there's a window, a couple controls here to select difficulty. And the main thing that you see on here is a canvas. This is actually using a control set for the tiles, but each of the items is a canvas. So it's a canvas control set that draws the number of tiles that you need on here depending on the difficulty level. And you can see each of those is a canvas that's right down here that knows how to draw itself, essentially. And these are obviously very simple tiles, so it's just a box with a number in it for the particular position of the tile. This also makes use of a few sounds that you actually probably couldn't hear. I guess I can only hear them in my headset here. But it plays a few sounds as you're clicking around. And that's just the icon. There's no significant graphics in this particular project because it's just drawing tiles as boxes. So you can see it's checking here if any of the mouse button is clicked, it's calling the action event handler, which is there, and find that there, which calls other code to move things around. There's a timer that runs in this particular case that is responsible for checking if you've put the tiles in the proper order. And then if you have, it tells you that you've won. And a variety of support methods here that create the grid using whatever size you need based on the difficulty. Moving tiles around. Deleting tiles for grid creation. Shuffling them. This makes sure that the games are always winnable. It starts with the tiles in the actual order and then randomly shuffles them a number of times so that you're guaranteed you can put them back into the original order. All right, we also have a web version of this to show how you can create similar types of apps on web and desktop. Slightly different layout here. The web version still has difficulty levels, but does track high scores. And this version, rather than using a canvas, is actually using a container to add each of the tiles to the web page. But other than that, it works the same. A little bit more animation here because on the web side there is a control called the web animator that allows you to slide, or not really slide, but to move controls around. Any control, a variety of ways, including just from position to position. You can also do spinning and a few other things. So by taking advantage of that, we can slide these pieces around a little bit and make them look nice. I'm having trouble with my end game here, taking too many clicks. I think my record is under 20, but I'm not setting any records here today. And this is set up to actually save the high scores only if you type your name in, which I did not do. So you can see again how this is good to compare and contrast the Sliders desktop version with the Sliders web version. A lot of the code is very, very similar, but there are obviously little tweaks between the two, and it's very handy to see how those are used. This here is the animator control that is added to the page that is used to actually show the animation of the tile sliding to its new position. All right, so we take a quick look at the example games that are included with Xojo. Oh, I missed one. I didn't show the battleship game. Let's go back and take a quick look at that. As soon as I find it. Had that one in the wrong folder. Now this particular game is not included with Xojo, but I imagine it will be once I get a chance to clean it up. This is actually used at the last two XDC conferences, Xojo developer conferences, for the battleship games at the end of the conference. And you can see here this has some animation in here that's firing the pieces for the battleship game. You don't hear the sound effects that I am hearing in my headset for when you actually get a hit or when you get a miss. So that's an interesting little game. That game actually used in the contest allows you to provide your own algorithm for how you determine how to specify where you want to try and do your shots to see if you can hit any of the ships. And it comes with an example battler that's kind of random. But let's see if I can bring up the main screen here. As you can see, it is a lot of canvases. And timers. And that's, again, I'll repeat over and over, a common theme you see with games is you're going to need a canvas to draw your pretty pictures, and you're going to need a timer to update it. Now we're also going to take a look at a variety of third-party games that were created using Xojo. I particularly like this one here. It's a clone of the Flappy Bird game that you see everywhere these days. I think people have even made versions of this game for old school computers from the 80s like Commodore 64s and Apple IIs. But this little game completely made in Xojo, so let's take a look at that. And this game is very simple to play. You just get a little bird here. I'm pressing the up arrow key to make him flap up. When I don't press the key, he drops because apparently there's gravity in this Flappy Bird world. And you can see there's little pipes you can't bump into, or if you do bump into them, it's game over. And apparently they're toxic because the Flappy Bird appears to be dead. And if you make it all the way to the end, you win. But as you can see here, this giant thing is actually using a single display, if you will, that appears to be an OpenGL surface. See, and this has a lot of more sophisticated code under the hood. I did not create this game. I will get you the link to the clever Xojo developer that did. But as you can see, it doesn't look like much when you look at the main window because everything is happening underneath the hood. And it was kind of fun with this particular game is I got this running, put it on my son's computer. We sat down with it, started going through the code, and we were able to figure out how some of the things worked and tweak certain things. So we could make the bird move a little faster. We can make him flap a little higher when you press the key, make him drop a little quicker. The favorite thing my son and I did is we turned the bird into a ghost so that he could actually fly through the pillars without dying. My son thought that was pretty cool. But I point that out because learning from how other people created games is one of the best ways to learn how to create games yourself, if that's something you're interested in. Because as you can see, just by looking at these, even some of the simpler examples we looked at earlier had quite a bit of code, and then you get to a game like this, which looks like it would be relatively simple. there is a tremendous amount of code behind the scenes that's making it do its thing. All right, so that's the Flappy Bird game, and this here is a blog post I wrote earlier in this year about this. It has links to the download and the forum post from where the user originally created this and posted their little write-up. All right, this game here is it's not really a game. This is more of a little demo. This is something that Mark Zeter did at the XDC conference in part of his object-oriented session. And I just want to show you this to show an example of some animation that you can do. And this again has the same overall concept. So you can see I can use the arrow keys to move the bottom ship, and the other ships are just moving around on their own. And surprise, surprise, this is done using canvases, objects, and timers. It's not actually a game. It doesn't do anything if you reach, if anything touches or anything like that. It doesn't, ideally you probably would be enhancing this to maybe shoot these ships that are coming down at you. And then if they get hit by your missile or whatever, they would disappear or trigger an explosion animation and then disappear, that sort of thing. All right, and you can see how this particular project is laid out with a lot of classes, a timer, and various graphics for the ships that are used to draw on the screen. All right, now we're getting to more advanced things. This is actually kind of like a game toolkit written in Xojo. This is by Elaine, whose last name I will probably mispronounce, so I won't even try, but you can head over to his website, alwaysbusycorner.com, and he has all kinds of excellent projects. We'll actually look at a couple of them here. This one is a 2D physics engine that allows you to put things into a world that has actual physics. So there's gravity, the objects can interact with each other in certain ways. And we'll run this demo here so you can see. So with a toolkit, you don't have to do all that back-end code yourself. You can work on more of designing the game. And for an example of something that uses 2D physics engines, if you ever played Angry Birds, that's a type of game that has a 2D physics engine in there because little towers that contain the pigs that you have to knock over are designed using the appropriate blocks and whatnot. And the 2D physics engine handles what happens when you apply a certain amount of force to one end and the falling action and all that other stuff. So you don't have to worry about doing all that. You're using the toolkit. So let's open up this project. This is a very big project, and obviously this sort of stuff is complicated. Creating games is, generally speaking, a difficult task. You do have to know a fair bit about math and other more advanced programming concepts. So you can see here, this is the demo. I can use the arrow keys to move this little cart with the wheels around, and you can see it can bump into that little gray blob thing. And you can see as I'm moving around on this little suspension bridge, as you will, it interacts based on the weight of the blob and the little cart moving around on it. I can shove this blob over all the way to the end. It'll hit this other piece, and these things will fall. And they're all doing that based on what's defined in the physics engine. And apparently that blob is defined to be too heavy for the cart to move up, so I can't get it up over the hub there. Oh, maybe I can if I get enough speed. So yeah, I threw it down there. It'll fall and then probably continue to bounce for a little while. as, and it bounced back up to the top. So you can see how that uh, is pretty cool because the toolkit is handling all that, and it just has defined essentially the board you're playing on and the various pieces and what they're how they interact with the world. This is incredibly cool. I have to say, when I have more time, I really want to sit down with this and figure out how to use it to make some little games that would be kind of cool, because it's nice to start with a toolkit that can really, take you many steps ahead in your progress to create a game than if you were trying to do it all by yourself from scratch. So definitely check out the 2D physics engine here if you haven't already. And also, he's created a 3D engine, similar location. And as you might imagine, this is even more sophisticated. And this will actually have a little robot that walks around. Let's take a look at that one. So here I've got a little robot that's kind of 3D. I'm using the arrow keys to move him. You can see how when it reaches the steps, it interacts with that appropriately, and the legs are moving up, and then they'll be able to move down. And I can turn off some of the layering with other key controls. I can stop the robot or set his speed. This particular little demo, he just walks until he reaches the end of this particular path that's been defined. And I can't even begin to describe how this stuff is implemented. It's way over my head, but certainly, again, something really cool to dive into, to play around with when you want to get a head start at creating games like this. You can see, a tremendous amount of effort and work has been put into this with all the class structure and the code that is under the hood here. So definitely take a look at this for any 3D game aspirations that you may have. All right, the next third-party example we want to take a quick look at here is Super Sprite Surface, which you can get from here. Unfortunately, this particular project is a little out of date, has not been updated for Xojo. So it does work with Xojo, but it does not work with Cocoa applications. So you're out of luck there if you want to actually create a Cocoa app using Super Sprite Surface, unless you want to dig in and update it yourself. The source code does appear to be available. But let's just run this real quick and see some of the things that it's capable of. Sprites are the sort of thing that allows you to move things on the screen and track their interaction with other objects that are on the screen. Very common in 2D games. Standard example would be something like, say, Asteroids, the old Asteroids game. The asteroids would be sprites, the spaceship would be a sprite, and you'd be able to track what happens when they touch or bump. The missiles you fire could be a sprite, that sort of thing. So I'm just going to run the demo app here rather than open up the project. So this is the one I took for the screenshot. So you can see here there's a little top view of a map. There's a fellow that's in the center, and I can use the arrow keys to spin the map and simulate him walking. When you hit a wall, he stops walking, he doesn't walk through the wall. Personally, I find this entire map spinning to be a bit nauseating, and I'm going to stop spinning that now before I get myself ill. And we'll move on to a couple of the other ones. Simulate some clouds there. This is showing these little things spinning around and kind of bonking into each other as they're floating around the screen. Yeah, I don't know what other things are in here that look. Yeah, that's not terribly interesting. More spinning things to try and make me dizzy. But as you can see, this can do quite a bit of stuff, and certainly worth checking out again to help you get the maybe get a head start on a game of your own without having to again go through all that initial work that is required. And this is a pretty common technique of starting with a toolkit. You probably, if you're familiar with first-person shooter type games, Halo, Doom, Quake are the older school ones. Those were always built using a main toolkit, and then more of the design went into the actual levels and the characters and whatnot, just because it is so much work to build those toolkits. I got a note here from Steve that says his dad and him messed around with the 3D robot example and managed to mess up the gravity so the robot was fast enough for it to glitch it out. And it is incredibly fun to play with other people's games and kind of hack them up to make them do things that weren't really initially intended. All right, so we've looked at a few example games that you can look at. Now let's take a look at Cookie Clicker, which is the world's simplest game. This is a example of a little exercise I did with my son when he was expressing some interest in creating games. And I, as you may have observed by now, am not a game maker. So my instructions to him were, well, pick a simple idea. Well, it turns out that he has this game on his iPad that he and his friends love, which I think is kind of inane, but nonetheless, I suppose it qualifies as a game. And I didn't even bother drawing a nice looking cookie here, but you can pretend this brownish circle is a cookie, and notice as I click on it, the number increases. That is the extent of the Cookie Clicker game, my friends. It is incredibly silly, but the real version has extra things you can buy with your clicks. So here I can click this auto button, and it subtracted the price from my clicks, and I forget how we particularly coded this, but it will automatically click the cookie for you as long as you have the app open. I don't know, something like every 5 seconds or something like that. And you can see the clicks are increasing even though I'm not clicking. And but I can continue to click myself, and then if I need a break because whoa, this clicking is really hard, I take a break and I still can get some free clicks in this way. The iPad version is essentially this with a lot more things you can quote buy with your clicks and perhaps a fancier cookie graphic. But it was very fun to make this with my son because this obviously does not need really any code to speak of. There is a canvas that draws a circle. That is our cookie. Ideally, I probably would find a nice picture of a cookie and use that in its place. There is a button here that activates the timer that will auto do a click if every period of seconds, and when the mouse is clicked, it calls the click method, and surprise, surprise, the click method increases the number of clicks. So, just a handful of lines of code in this application. It makes a quick little game that can kind of start to get, the young ones interested in maybe even programming and, throwing together little games themselves. So that is the great game that is Cookie Clicker. But let's move on to something slightly more interesting. And this here is a game I call 2K, which is essentially a clone of the 2048 game that you may have seen also on your devices. I think this might have first came out for an iPhone or iPad, but this is essentially another type of sliding number game where you have to match up numbers, and when you do so, they disappear and new ones slide onto the screen, and you have to try and get as high numbers as you can for the most points. So let's open up this one. Now this probably is the epitome of my game design skills, which isn't to say very much. I essentially completely copied the look as close as I could of the 2048 game on my iPad. I added a little controller here to click which direction you want to slide the tiles. So right now if I click the left button, these two tiles will slide all the way to the left, and a new tile will appear somewhere on the board. So those two tiles slid over here to the left, and this here is the new tile. I could slide them all to the left again. The 4 and the 4 would combine and make an 8. The 2 is going to stay right where it is. And the new tile appeared over here. I could now slide them up. The 2's would combine to make a 4. And then a new tile would appear. And so on and so forth. Kind of like this game. I find it relaxing. Now, I didn't have the official rules to this game. I kind of just inferred them by playing the game. I have no doubt that I probably messed up one of its rules in some manner, but I think I got the gist of it. And you can see, you essentially each time you combine a tile, those are the points you get. And the goal of the game is to get the highest tiles you can, thus the highest score that you can. And I am not, I gotta stop. I gotta force myself to stop. Please, somebody make me stop. All right, I'll come over here and click quit. I could play that game all afternoon. So you can see the 2K game here. Main play area is just a giant canvas, but the other areas are also canvases. There's a canvas that shows the little logo, canvases for the high score displays, canvases for the little arrow controls. The only thing that's not a canvas is just really the label here and the restart button. And you can see each of looking at the score canvas, for example, you can see this is just drawing the score in a particular way, getting the score property that's been set. And looking at the various slide canvases, you can see they call the methods to slide in certain ways, depending on which button was clicked. And then these things have code that determines if there's tiles to slide, slides them over, combines them, updates the score, all that fun sort of stuff. Adds new tiles to the grid as appropriate. There's a tile class that's here that is really it doesn't actually draw anything. It just has some properties to track that it's new and which number it contains. When new tiles are added, they're either a 2 or a 4. That appears to be random, so this just tracks that information. And I did also, again, to compare and contrast, I have here a web version of this game. And it plays the same sort of way. Actually, it looks exactly the same. This is using a web canvas instead of it's using a web canvas. The desktop one obviously used its own canvas control. But other than that, the code is, I think, almost exactly the same. And you can see it has the same tile class, same general layout here, but these are all web canvas controls. Same methods, probably same type of code in each method. So a very, very similar coding style was able to make a web version of this game. But that is the 2K game. Now, I like the 2K game. Probably played it far too much prepping it for this particular webinar. But it does need some enhancements, which I present as exercises for those watching and listening to the webinar. Obviously, the source code will be made available, as will these slides, so that you'll have access to all the links and whatnot. And other projects will be in the download package when I put it up later this afternoon. So the first thing, my 2K game doesn't actually know when you've reached the end. And you've reached the end when there's no more room for new tiles to add, and you can no longer combine any tiles. I don't have any code in there to check that. So when you're playing, essentially you'll know you reached the end when you can't slide anymore, and then right now you can click the restart button to start a new game. But it would be nice if it knew that the game was done. Right now I have it set up so you have to click one of those little arrow controls on the screen to slide the tiles. As Jeff pointed out to me, keyboard control would probably be a heck of a lot easier than all that clicking. Keyboard control would be very easy to add, so that's a little exercise. Something that's not quite so easy to add would be animation. Right now you noticed when you saw the game moving that the pieces kind of just appeared in their new positions. When you slid them over, they just appeared all the way to whatever side you were sliding to, and the new tiles just appeared. It would look a lot slicker if the tiles actually slid, and if new ones kind of slid from somewhere else onto the board. So adding animation would be a pretty nice thing to add to the game. That would take a lot more work. It's going to need, as I've mentioned before, some timers, probably additional objects to track things so that you know what to draw for the animations. Right now there's only a very simple data structure that's tracking the position of the tiles on the grid. And you're probably going to need to track the current position, the new position, so that you can animate in between the positions. So that would be a more challenging thing to add, but certainly would make the game look a lot nicer. And something that's not necessarily graphic related, but being able to save high scores would be nice. Right now, I'm not even certain that it might save the high score when you quit. I think it does save the high score if you quit and relaunch it. But having a more global place to save high scores, maybe using a Xojo web app to connect to at the beginning, pull down the highest high score, and then your high score, that sort of thing. So that makes you have more of a community type design for your game. All right, so we've reached the end of the keynote and near the end of the presentation. So you all know my email address, paul@xojo.com. You're always welcome to shoot me an email, ask some questions. I am now, before I forget, because I did forget earlier, going to run the usual polls that I run on these webinars. And while those are running, I'll take a gander at any questions. All right, looks like that poll's about done. Let's move on to the next one. All right, next poll. And our last one. All right, great. Thank you, everyone. I got a few questions here. Let's see here. Ablia was noting that most games he sees are full screen, but most of the examples are running in Windows. Is that only for example? And yeah, I guess that is only for example. It also makes it easier in some cases to set a particular fixed size window just to work with. But you could certainly just run the game at full screen and hide all the window decorations, if you will, so that that's not visible. And then essentially your game would be running at full screen. You may even want to design your game so that the graphics redraw so that people can run it at any particular size they want. Let's see here. Bob is asking about animation, and the timer would need to fire every so often to show the steps. And what's a good rate for that? Yeah, exactly. Your timer is going to want to run pretty often to do the animation updates. And what's a good rate depends on what you're actually displaying. Generally speaking, if your game is able to hit something like 30, as they call it, 30 frames per second of the animation, people are going to be pretty happy with that. That's normal animation type speed. So you could set the timer to run at that rate, and as long as you make sure your code is not taking longer to run than your timer is firing, you'll have excellent animation and your app will look nice and smooth. Your game will look nice and smooth. You can certainly bump it up higher depending on what you're doing, but 30 is probably a good target to try and shoot for. Let's see here. Glenn is asking if you're animating the tile movement on probably the 2K game, do you redraw the whole canvas for each pixel shift of tile? Well, how you want to handle the animation is up to you. Redrawing the whole canvas is probably the easiest thing to do because you can just you can just draw your image in memory with everything at the new appropriate positions, and then redraw the canvas. That's essentially how it works now. Because then that's why you don't see any animation. It knows what the new positions of the tiles need to be, so it draws them in memory at that position, and then the canvas when told to is just redrawn with the new board state, which has everything in its appropriate positions. To do the animation, you need to redraw stuff at the intermediate positions, the positions between the current and the final state, and that's the sort of thing where the timer would need to run more often, and you would need to track that so that you know when the pieces have finally reached the final state and what they started at. So like I said, it is a bit more work to figure out. I haven't had a chance myself to sit down and just design up how I want to track that information, because it's mostly about tracking it so that you have all the data you need so that you can draw stuff the way you want. Right now, that information is not in there because it is only tracking the current board state and the new board state, and then nothing in between. All right, I don't see any further questions here. Oh yeah, one here just popped up from Juiced. How do multiple timers work? What if the timer fires? Well, another action event is running. We're not really going to have to worry too much about that. I mean, all of Xojo operates in a cooperative threading mode, if you will, or timer mode. So things are still going to happen one after another. So the two timers will never technically fire at the exact same time. One will always fire first, and it will do its thing, and then the other one will fire shortly or immediately thereafter and do its thing. If the event is still running, it will finish to completion, and then when the other timer runs, it will do its thing. So the important thing to remember with this too also is timers do run in the main thread on Xojo, which is why they're able to update the user interface like this. So some of that contention is already handled automatically for you. All right, I do want to remind people here the next two webinars for this month. Next week is a guest webinar with Bob Keeney talking about using Xojo with consulting. He's kind of an expert on that, and I would recommend you tune in if earning money using Xojo is something that you want to do. And then to cap off July, I will be doing the Introduction to Object-Oriented Programming 201 session. Unfortunately, the 101 webinar, the recording failed and has not been available on YouTube. So I will be repeating the 101 session in early August for those that missed it the first time and obviously have not been able to watch a recording. So if it turns out you missed 101, you could certainly come to 201 and then watch 101 later, or maybe you want to just catch the recording of 201 after you've watched 101. I apologize for the order, but I think we've got the recording issues straightened out. And just one more question here on the list. Cliff is asking, are classes a good idea for tracking information because of reusing things in multiple games? Well, I don't know that classes, the reuse in multiple games would matter much for classes. Just in general, you're probably going to want to take advantage of classes just because of the object-oriented ability to encapsulate information together. It's very handy to have a class that represents an object in your game. In fact, that often is one of the better uses of object-oriented. It's a little easier if people understand. If you've got an actual tile on the board, having a class called tile makes it really easy for you to comprehend what you're dealing with. If you're making a game, like asteroids, you could have a class for each asteroid, a class for the ship, and you're able to track that stuff a lot better than if you just had, scattering of variables all over the place that were tracking individual things. So certainly taking advantage of classes in your game design will probably simplify it a lot for you. All right, and of course, webinar recordings are always available here on the main webinar page at the bottom. And you can also go to our Docs Wiki, which is the main source. If you scroll down a little bit, there is a webinar link here. And this has links to the YouTube page of the video, downloads that accompany it. I will have the slides and projects up today for you to download for this webinar. And of course, I also do recommend that you subscribe to our Xojo YouTube channel on YouTube. You can also subscribe to the RSS feed so that you know when new videos are uploaded. And one last question that popped up here. Alan is asking if you can use a timer without making it a control. And absolutely, you can use a timer without making it a control. To do that, you can subclass the timer, and that'll expose the action event handler that you can then implement. Or you can use the add handler command to tell the action event handler to be mapped to a method that's on your window, for example. It's often easier to put the timer on the window just because if the timer's on the window, you can also more easily access the other controls that are on the window. But you do have essentially 3 different ways you can deal with your timers. All right, I think that about wraps it up for this week. I want to thank everyone for attending and have a great rest of your day.